Good time of the day, everyone, wherever you are. By the way, please drop your city and country into the chat so we know which communities we're serving. Welcome to Los Angeles Data Platform User Group. Thank you for joining us today. My name is Steve, and I'll be moderator of this virtual meeting. I'll be joined by Yelena, and Yelena is going to be helping out and also doing a t-shirt raffle. Please visit our Eventbrite or Meetup to get notified on any upcoming meetings. You can also send us an email if you want to. All these hyperlinks are working, so you can click and it will take you to the right place. If you're attending us for the first time and would like to follow us on different social media touch points, please feel free to click on the link. It'll take you to the right place. And there's also opportunity to join our mailing list. We're sending weekly newsletters with important links, also notifications of upcoming meetings, notifications on published YouTube Rumble videos. And this way, you can get notified right away. And this event is sponsored by Microsoft Tintri and Data Driven Technologies. So everyone knows Microsoft. Not many people know Tintri. Tintri provides storage, virtualized storage. And probably not many people know about Data Driven Technologies. Data Driven Technologies is the organization behind Los Angeles Data Platform User Group monthly meetings, as well as our mega once-in-a-year event called SQL Server in Los Angeles, or as we call it now, Data SQL Server LA. At the end of this meeting, we'll be raffling a custom t-shirt. Please scan QR code or follow this link to enter your name. And a couple of disclaimers. The color of the t-shirt might be not blue. We can only ship to US. And you need to be present to win. During this presentation, please feel free to drop questions in chat, or I don't know if we'll be able to unmute, but that's an option as well. And without further ado, let's move to the rock star of today's online meeting. Bill, please take it away and introduce yourself.
Thank you very much. I'm Bill Ramos, Senior Product Manager Technical for the Aurora Postgres team. My main responsibility is Babelfish, and that's what I'm here to talk about. So what I hope to do here today is give you a good overview of Babelfish, when's a good time to use it, how to figure out, if you're ready for it, and why don't I just get right into it, okay? So I need to figure out how to share my screen, or am I sharing my screen right now? What do you see there, Steve?
Not yet. All I see is a PowerPoint from you.
Oh, that it says LA Data
Platform proudly presents.
Okay, we're good. I'm going to kill that then and get right into it. So first off, what is this thing called Babelfish? Now, AWS.
Bill, are you sharing different screen now?
I hope it's a browser.
No, not yet.
Okay, let me go ahead and stop sharing and resharing just to make sure.
Okay.
And so we'll go ahead and, now I lost my share button. Share, there we go. Okay, share screen window, share entire screen, and we'll go with this screen that has a browser here. And Steve, if you could let me know when it's up, or.
Sure. Not there yet.
Okay. Must be kind of drag if sharing doesn't work.
Well, you basically shared that before.
Yeah, I was. Yeah. So it's interesting. I've got stop sharing as an option. So that's a problem. I can't. Is there something on your side that you need to do to make my screen show up?
Nope. Nope. I made you a presenter, so.
Okay. And right now you don't see anything on the presentation screen, correct?
Correct. Yes.
Okay, let me try it again.
No problem.
Start sharing. Here we go. Do that. Entire screen. Click. Share system audio. I don't think I want to do that. Okay, share. And
It seems like it's trying. It's got a black rectangle. It's so it's not like your image. It's trying to share, but it's failing.
oh, okay. So we're going to spend the first 15 minutes on editing this video to like figure out how to share. Is that it? And it was working before, you said, right?
Oh, yep. Okay, it's now. I can see it now.
Okay, so you see using Babelfish for
Yep.
Aurora Postgres. Okay,
I'm
so
still okay. Now I'm seeing it too. Okay.
awesome.
Wonderful.
Hopefully there's not much of a delay. And then see, I don't see the screen image in the Teams browser, so I'll have to trust you. So when I say I'm going to Management Studio or whatever. Okay, so what I'd like to talk to you is the mysterious third way of being able to support SQL Server on the Amazon Web Services platform. So today, everyone knows about running SQL Server on EC2 instances. Basically, it's running it on a compute instance within the Amazon EC2 framework. You set up your connectivity, for your client tools. You set up your storage. You pretty much manage it on your own. Then the next alternative, which has been around for a while at AWS, is RDS SQL Server, and now RDS SQL Server Custom, that allows you to run SQL Server as a managed service. Make it very easy to set up always-on availability groups and be able to do the backups for you, and so that you don't have to worry about a lot of the mundane things that are associated with the database. And now we have the ability to run SQL Server, T-SQL Server applications on Aurora Postgres with Babelfish. So essentially, what we've done is we've introduced a new language on top of the native Postgres engine called T-SQL that works just like the Postgres native language or any other language that allows you to run T-SQL in such a way that you get pretty much all the basic features that you would have in T-SQL you can do with Babelfish. What I'm going to do today is I'm going to show how you basically set up a Babelfish cluster, create a database with tables in it. I'm going to use the Northwind database, the sample database that's on GitHub that I've got running on a SQL Server right now on RDS. And I'm going to copy the data from that RDS SQL Server into my new Babelfish cluster. And then I'm going to run T-SQL queries and show you some of the basic things that you can do with Babelfish once you get your data in. So with that, I'm going to try to avoid most of the slides. I might want to I'll talk about some of the advantages of Aurora a little bit later, but I want to get into the meat as to what you can do with Babelfish. So the first thing you're going to want to do with Babelfish, how you get started in Babelfish, is you'll go to your RDS console. Now, again, I'm assuming that you have an AWS account. If you don't have an account, there is it's very easy to set up a trial account, and you can go ahead and use the various services. In this case, we're going to be focusing on two core services, which is going to be Amazon Aurora and the database migration service. So with that, I want to show how to create a database, and like the standard cooking shows that are out there, I'm going to show you how it works, and then I'm going to pull it out of the oven right away and show you how to connect rather than waiting for things to actually get instantiated. So When you go to your RDS console and you've logged into your console, what you do there is you'll go and hit Create Database. There'll be a various set of options that you can do when you're creating the database. Like, if I set up a SQL Server database here, this is going to set up an RDS SQL Server. Likewise, if I do Postgres, MariaDB, or MySQL, these are all RDS. And then we have Aurora MySQL and Aurora Postgres. For Babelfish, we use Aurora Postgres here. And again, the reason we built Babelfish on top of Postgres is because of its language extensions. So Postgres has this ability to add in various extensions, in SQL Server as CLR assemblies, or T-SQL code that you put in master database with SP underscore whatever so that you can find it across your area. But Postgres has come up with a way of extensions where you can do, native, just basic Postgres code. You can run, create extensions with the C language. And in fact, we have new capability both in Aurora Postgres and RDS Postgres called trusted language extensions, where you're not limited to the extensions we support. You can create your own using the trusted language extensions there. And so it's that capability of Postgres to be fully extensible that allowed us to introduce the T-SQL language and be able to support the TCP/IP protocol that your client applications use to talk to SQL Server to be able to do that. Okay, so you'll get started. You'll select Aurora Postgres. You can show in the little drop down here, you can say show versions that support Babelfish Postgres. You always want to use the most recent major version when you're getting started in Babelfish. In this case, as of today, this video, the 15.3 release is the most current release. And the reason that you use the most recent major version is that's where all the new features go. So when a major version comes out, we use that latest major version to release fixes. For the minor releases, we'll release basically patches to correct, common problems that we've seen from customers and things like that. And we'll also fix that in the most recent version. But we typically don't add features for better support of the T-SQL language unless it's in that major version. The other thing, I should point out is that Aurora Postgres, if you want to give an idea of the rate of innovation that we're able to do in Babelfish, is we use the quarterly release cycles that the Aurora Postgres community comes out with, where they do essentially one major release a year and then 3 minor releases. And we follow that same pattern with Postgres. So every quarter we're innovating Babelfish. Okay, since I'm just doing a demo here, I'm going to use dev test. And by default, what this does is when you create you'll create an Aurora cluster, and inside of that will be a Postgres database where Babelfish runs everything inside. When you do dev test, it's basically going to create a cluster with one compute instance. Now, Aurora supports up to 15 replicas, read replicas, in addition to your writer, so you can actually have read-only workloads going against your Postgres database, like or MySQL for that matter, with Aurora MySQL. So what that allows you to do is, with no extra licensing, because these are technologies based on open source, you don't have to pay the licensing. You can easily configure read-only workloads within an Aurora cluster to be able to access, your database servers. So that's a really cool feature, that you get with Aurora, is that instant, ability to create replicas. In addition, with those replicas, you can also define various replicas as failover targets. And so you can, depending on if you want to have smaller replica sizes and then the larger replica sizes to match your main writer replica or writer instance, you have the ability to say, I want to fail over to maybe these 3 replicas, one after the other, depending on what's going on, and then go, to the lesser one. So you have that ability, that extra flexibility of defining how you want your failovers to go. Now your DB cluster identifier, this is going to be unique within RDS. We'll do something like LA data platform, Babelfish. And I like to put in here the version that I created with, in this case, I'll do 15.3, and maybe just to remind me when I'm using tools like Management Studio or other Postgres tools like dbeaver or pgadmin, where this thing is located. So I just put it in the name. And so I am in US West 1, I believe. Yep. Okay. Now, because I'm creating a Babelfish cluster that acts like SQL Server, rather than using the Postgres master username, I like to use SA, of course. And I'm going to go ahead and, you have the ability of using the AWS Secrets Manager. This is a place where you can stash your, the name of the service identifier that you want to go with and the password in there. You can use the Secrets Manager to set that up. I'm not going to do that today. And I'm going to hopefully get my passwords to match here with the master password. Okay. Another thing that we just introduced with Aurora. So on Aurora, you're building a standard. Your build based on your compute, the amount of storage you use, and how many I/O operations you're doing over your billing cycle. I/O optimized is designed to kind of prepay for all those I/Os. Think of this as like the optimized storage for EC2 instances or for RDS, where you can basically say, okay, I want to go as fast as possible, which the Aurora platform provides, not pay any of the I/O cost, but I'm going to pay a little higher cost for my storage and my compute. But for demo purposes, things like that, standard workloads, you want to start out with Aurora Standard, and then you can eventually see, based on your I/O cost, whether you want to switch over or not. We have a variety of instance types that you can select. You do have the ability to go serverless. And so with the serverless, you're basically defining these Aurora capacity units. So you kind of think of it as like maybe a core, a virtual core, and an amount of memory, and you can define the min and the max. I personally like using the memory classes, and I personally like using the R6G class, which is the Graviton processor, which offers better performance at a lower cost, and you get some really good throughput. Typically, just starting out, you can go all the way to a 24x large instance, which gives you essentially 96 vCPUs. Today, I'm not going to actually create this after all, but you can go ahead and I'll define something small. Again, based on our templates that don't create a replica, I could create the replica. There's another thing you can do is you can tell it to actually set up a EC2 compute instance that could act for all your tools and within your virtual private network and get that set up. That's kind of a good way if you don't have an EC2 instance for your RDS instances and you don't want to expose your database endpoints to the public. That's a great way to get going. I'm going to go with the standard IPv4 interface I've got. I'm going to be using my default. Generally, it will create these private cloud or the virtual private cloud VPC networks for you on your first time. In this case, I am going to allow public instance, and then I can use security rules to basically say, hey, anyone using my corporate VPN, they're the only ones that can access this area, and I can, tune that down to, other things with security rules. So, you can, depending on how secure you want to be, because I'm going to be using my local desktop to connect to the Aurora instance, I'm using public access. Okay, the other thing I need to do is, again, so I don't have to, I have a well, I guess I don't have a predefined here. I guess I've added already for the access. There's an option here to create an RDS proxy. RDS proxy currently is not supported for Babelfish, but it works great for Aurora Postgres connections. So if you do have an option with Babelfish to actually use either TCP IP or Postgres connections to your database. You can change the database port. By default for Babelfish, it's always going to be 1433. It's easier just to leave the defaults. And then the next option is the turn it on. Makes it faster, cheaper, low risk migrations from Microsoft SQL Server to Aurora Postgres. So we're going to go with that. We added a new enhancement with our Babelfish 3.1 release in the spring to actually be able to support active individual logins for Active Directory users. And so we have a way that you can configure that up. You can read our documentation how that works. I'm just going to go straight with the moral equivalent of SQL authentication. Okay, different things that are cool. Performance insights. This is very similar to SQL Server Query Store, where you can see what queries are taking up the most time, look at the wait stats, and use that as a way of finding out where your queries are spending their time. And the other thing we need to do is make sure to expand out additional configurations, because there's a couple things you want to do here. Have Babelfish the first time you want to say create a new one, and when you do create a new one, make sure it lines up with your version ID. What this is going to do is create the parameter group with all the things that are needed to wire up Babelfish. Once if you don't, if for example you create a cluster that doesn't have Babelfish, there's no way to turn it on. So this is like a one-time shot at it. And so by having it create the parameter group for you, it's going to do all the right things to get Babelfish working the first time. The other option you're going to have is this single database mode versus multi-database mode. Think of single database mode as having a server with a partial contained database where you can only have one database in there. So that's it. You get one create database statement. If you want to create another database, well, you have to drop that one and create a new one. I always recommend, and we recommend to others, is use the multi-database approach. And I'll explain how that works here very soon as we get into Management Studio. Okay, all the other options here are just fine. Enable encryption. This is basically making sure that you're, in Aurora, your data is encrypted by default, and you can also enable encryption for all the communications. Another important feature is enable auto minor version upgrade. Again, we typically run minor version upgrades about twice a year or, right now, and the whole idea is to get you to that next version. We have a feature called zero downtime patching, which also applies to minor version upgrades, which minimizes the downtime to seconds, or we try to get it under a minute, where during that upgrade, we'll cut you, if you have replicas, we can minimize the downtime quite a bit better. But the whole idea is minimize that effort of what's going on to the minimum. And when you do that, this auto miner version upgrade, you won't really know it took place, but it's a good thing to have to make sure that you've got the latest patches and everything. Okay, when you're all done, you're going to go ahead and create a database. So rather than create a database, I'm going to show you what it looks like already afterwards and point out a couple things. So I'm going to go back over here and go back to RDS, and it's probably going to tell me, no, it's just going to go right to it here. Okay, so when it gets created, what you'll see in the RDS console is you'll see under database instances, or you can go to databases over here on the side, is you'll see your all your RDS and Aurora databases in one place. And so here's my RDS instance that I'm going to be using to copy over the data. And you can see here there's a cluster and then an instance. Now, when you go ahead and create an instance, you can actually connect to this directly. However, you won't take advantage, it won't be able to take advantage of the failover capability. So if this fails over, it could fail over to a read-only secondary, and then all of a sudden, hey, wait a minute, why are things not working the way they're supposed to? So even though you see an endpoint here for the instance, this is not what you want to use. What you do is you go to the cluster here, which is this top node, and you'll look at connectivity, and you'll see endpoints here. And so you see here, there's a endpoint for Postgres and endpoint for Babelfish. And so it's telling you what to do for that endpoint. Oh, I should actually go here. Here's what I want to do. Here's my two endpoints. So you have a writer instance and then a reader instance. So what this allows you to do, this is like the SQL Server always on availability group active listener. So what you do is you provide that, like you provide the endpoint connection of your apps to the listener, what you do here instead is any applications that need to go, that have write operations, you want to use this endpoint. You can use this little square thing here to copy it. And your read-only nodes, you can use this endpoint. Now, when you're development, you're writing code and doing all sorts of things. So for tools like Management Studio, you're going to want to use this writer instance link. And this is going to be the server that you're going to connect to when you're using Management Studio. Okay. So other things to point out, you have basic monitoring capabilities here where you can see what's going on in your server. And this is just going to provide a high level view of kind of where you are, buffer cache hit ratios. We all know it's kind of the same across all the different engines. You have CPU utilization, commit throughput, all the core essentials that you'd expect to see in a database. Your logs and events. I remember when I first encountered Postgres, I go like, where's Profiler? I've used SQL Server, gosh, ever since it first came out when I was at Ashton Tate back in, I think it was 2000, around 2000. So I've been exposed to SQL Server for a long time, and then obviously the Profiler within Management Studio. But you have your events and logs, and it turns out you can turn on things like log all my statements to the actual Postgres log. And so that is actually something that you can turn on and off to do logging and essentially get the same capabilities as the SQL Server Profiler without having that separate tool. You would be able to see those logs in the display. The logs, however, are on the actual instance. So when you click on the instance, you'll see the actual logs for that instance. For some reason, my clicking isn't working too well. And then we go to logs here. And if I want to see what's going on with my most recent log, and just sort by the order and take a look at it. So this is where you find the logs. And again, these are, you can see how to turn those on by looking at the other configuration options. Okay.
Bill?
Yeah, go ahead, Steve.
And I'm guessing logs are not free, right?
Oh, well, logs are, they do have an overhead. So the more tracing you do, that it is, there is a potential for performance penalties, which aren't free. But the basic logs, there's a minimal amount of storage that's needed for those. If you turn on the option on the cluster to take those logs and route them to CloudWatch, again, you'll be paying a minimal amount of money to keep those, within your retention area. So essentially, for basic usage, they're incredibly low cost. How about that? Okay.
Thank you.
Yep. Other things I'll point out, again, configuration. This is a great way just to see, what's going on with there. And then the maintenance, this is where you're going to see if there's any pending maintenance that is needed. So it looks like I have a new operating system patch for my cluster. And so this is the place where you would do, for example, patching the operating system for this instance. And so you always want to keep an eye out for your maintenance and see where they are, and then figure out when to do that. You can schedule these in your maintenance window, and you define those, based on the week and the time, and it will go ahead and schedule it up. And so that's something you want to keep up on as well. Okay.
Quick question, Bill, you mind?
Yeah, go ahead.
For maintenance, like, is this something that can be set up where you can receive, like, let's say, just in my current environment, I have, several thousand instances.
Yep.
I'm not exactly going to go and look at every single one of them, right? So is
No.
there a way to set up reporting that would let me know what instances are crying out for maintenance?
Yes. And so the way to, this is not something I was set up to demo, but there's this idea of events that take place. And when a particular maintenance event happens, and this is only this only runs for about a few days that you'll see the events in here. But what will happen is there's a service called Event Bridge. And what you can do is basically look for the different maintenance events and have those surfaced up in a system health dashboard for your overall landscape. But in addition, as part of when you receive the event that the maintenance is available, with Event Bridge, you can set up code that would run then to go ahead and say, okay, I want to apply it in the next maintenance window for whatever the cluster has. Right.
Okay,
and
thank
configure
you.
it that way. So you can do that at massive scale with Event Bridge and being able to listen to the various events. And so there's a whole topic on RDS events that you can look for, and a blog post of how it works on AWS blog to get an idea.
I think if I will be able to answer Yelena's question in one sentence, is Yelena, you can still do your own reporting.
Thank you, Steve.
Yeah. So there is, you can also use the APIs. So for example, you can use the PowerShell commandlets for AWS that interacts with the common language or the command language interface, and be able to query all your instances that way too across your fleet. That's fairly easy to do. And manage it that way. So there's a lot of different ways to do it. With the querying, maybe on a daily basis. That's one less service you have to worry about with Event Bridge, but Event Bridge does make it a lot easier. Okay, so I think in that clipboard I still have that connection string, And what I'm going to do right now is I've got Management Studio. I think you're all aware of Management Studio, but what I can do, for example, I'm just going to, I already have a connection set up to the server already that I showed you, but I'm just going to show you what you can do for a new server registration using reporting registered servers. And I like to use registered servers to record these for one reason only, but I'll explain that here in a second. So what I'll do is I'll paste that endpoint in here. Again, if you went the Windows authentication route, you could do that, and it would pick up the Windows credentials, you know, that you've defined when you set that up in AWS. But I'm going to go with SQL Auth. Again, I have my username and password because I've already set it up in this environment. That's why it remembered. And then I tend to shorten this name down quite a bit in the registered server name. But the feature that I like the most here is the ability to use the custom color for this connection. So you can see I'm actually connected to it right here. And what this does is it allows me to, yeah, of course, I already have the same name in here. What allows me to do is whenever I open up this connection to my Babelfish cluster, I'm always going to see this particular color, which is a great way to keep in touch with what you've got set up. But like management, what we've done with Babelfish over subsequent releases is we've enabled more and more features with Management Studio. So once you're connected with your registered server, for example, let me go ahead and I'm just going to disconnect here. I'm going to go ahead and double click on that. And what that does is it will open it up in my Object Explorer. And I can go ahead and you'll see here, I've got no databases. That's good because I haven't created any. And this is basically you can interact with it mainly through the query editor. And don't expect to be able to create database or create objects through the Object Explorer. There are some other hidden mysteries in the way that Management Studio does this stuff through the SQL management objects interface that we haven't supported yet, but we're again, each release we're trying to get better and better. But because Babelfish databases are really quite different from a T-SQL database that you would create here, it's a very different thing. But what I can do is show you my first script of how you get started. Okay, so again, I'm connected to my cluster. Again, we're in this color here. I have things like use master, which do exactly what you think you do. We have, in addition to the classic @ version, we do support server properties as well. We support most of the SQL Server properties. In addition, we've created a Babelfish version property. And we also have at the Postgres level, we have a PG function called Aurora version, which will show you what version you're running. So I like to just make sure first thing I do is make sure I've got everything set up. Yep, Babelfish, latest version as of today, 3.2.0. And then our latest Postgres version. And then we have the classic SQL Server version. I should point out that in the version, we do show that you're running version 12, which is like SQL Server 2012, I think. I can't remember if it's 2012 or 2014. Anyways, you can actually, in the configuration file for your Postgres instance, change the setting so that if you have tools that are expecting to see a specific version of SQL Server, you can change this to match what it expects when you're using @ version. But this is a quick way to tell what's going on with your SQL Server. Just make sure you're hooked up right to the version. Okay, so we're running the right version. The other thing that we do with T-SQL is we do we want to make sure that correctness, the way that your app runs in T-SQL in terms of transaction management, what happens when you fail a transaction, or the data types, or indexes and things like that. We want to make sure that you get the same semantics when you want them. And the way that you control the whether to loosen how Babelfish behaves is through the stored procedure called SP Babelfish configure. When you run that, you'll see a list of various options that are available. For example, you can enable hints. Out of the box, Babelfish will actually ignore hints, but you have the ability to turn on Postgres hints. And we've got a help topic that describes how that all works so that you can go ahead and basically enable that. Other things we do is, for example, we can ignore miscellaneous database functions that have no relevance, or for replication when you're using, for example, identity columns and things like that. Now, what I recommend doing is when you have a new server and you're ready to go and you just want to make sure code just works, I recommend using the option of basically saying for all these settings, ignore them. So when you go ahead and run that, what that will do, when I look at this settings again, you'll see it basically ignores all these various options here. And so this way, I can run T-SQL code and kind of expect what I expect. Okay, create database. In its basic form, this is all you have to worry about. It underneath the covers, it's going to set up your Aurora storage that automatically grows and shrinks based on your usage. It's nothing like shrink database on SQL Server. It's all based down at the storage layer. So all the things that you would normally do with file groups and properties and things like that, you don't have to worry about. But I'm going to go ahead and create my Northwind database here. And then we've implemented essentially a lot of the database catalogs that T-SQL uses in the sys schema. And we've done that through a combination of either C code or T-SQL or even Postgres language, to implement these. And in fact, when I first started using Babelfish before it even released, I had no idea where Babelfish was storing things because they didn't even have sys.tables or sys.databases. So I was trying to figure out how did it do that stuff. But now that we've created Northwind, we can see here we've got our databases. And so that allows us to see the information. And I can go ahead and say use database. And again, you'll see in Management Studio, we changed the database here. We changed the context. You see the status bar get updated and we're all set. And in fact, if I refresh now the Object Explorer node, there's my Northwind database. Great. Now, I want to save, I'm going to assume that you're not all that familiar with Postgres. And I want to share again this kind of how Babelfish maps things to Postgres in general. There are these things. There's a catalog item called in the Postgres catalog called PG namespace. Think of this as sys.schemas. And what we do is we map to the Postgres namespace so that you can actually see, for example, that we created this database called Northwind. We have our T-SQL schema here. And because we did the multi-DB mode, we see the mapping of what Postgres did or what Babelfish does to a Postgres database. Now, what I'm going to do now is I'm going to shift over to dbeaver and show you exactly what's happening here. When you create a Babelfish cluster, I should say, when you create a Postgres cluster without Babelfish, you basically get one database to start out with called Postgres. And you can do a create database command and create multiple databases in here, and it will add them, into your cluster. When you create a Babelfish cluster, it creates Babelfish DB. And underneath that is a series of schemas. So first off, we have our own information schema just for T-SQL and the Postgres schema. We see schemas for master DBO. So master database is basically master DBO, and then we have the guest schema. MSDB, we basically use that to make Management Studio work. We don't do anything with MSDB like agent or backup history or anything like that. Is just basically enough in there to make SSMS work. There is a public schema here. You can add tables here in public, but you can't see them in Babelfish unless they're actually in the schema associated with here. Now, because I had this expanded before, I'm going to go ahead and refresh this. And when I refresh it, you'll now see the Northwind DBO schema show up. And then under that, it would have its various tables and things like that. So what we do in essence is we map everything into Babelfish DB, and then we use, basically, think of your T-SQL when you say create database. It's a virtual database inside here. We can easily support, hundreds of virtual databases inside this Babelfish DB. And we're always looking at ways to make sure that we can extend that, over time to support thousands eventually. But the whole idea is that you'll have all your databases inside of this Babelfish DB with the schema mapping that's taking place. So again, this is how it maps to Postgres. And what I want to do now is start creating some tables. Now, to save you the time and misery of using the generate script wizard, what I recommend doing when you're scripting out a database is do two sets of scripts. And the main reason is we're going to use the database migration service to copy over that data. And when you do that, you basically want to have your table along with any primary key or unique key constraint associated with that table. You want to have that in the table definition before you do your data migration using DMS. And so by doing that, you want to essentially script out your data with just the tables and the primary key. So in the generate script wizard, I went in and basically said, turn off all the other stuff like check constraints, foreign key constraints, defaults, triggers, all that stuff. Turn it off because I want the data transfer, that initial data load, to happen as fast as possible. Now, the other thing that I should point out is when we use DMS, we're actually going to use a Postgres connection. And what I'm going to do is I'm going to flip over here to DMS just to set some context here. What we're going to do is you have our, this is on the DMS user guide page, basically the overview of the architecture. Our source database is going to be our RDS. We're going to create a source endpoint, which is going to be a SQL Server endpoint. And what we're going to do is we're going to use a Postgres endpoint that's been customized for Babelfish with the latest version of the database migration service to go ahead, and we'll use the Postgres endpoint. And so when we do that, there's some things that we need to work around as we make the Postgres endpoint work better and better over time. Right now, what you have to do is any kind of image data type or var binary or binary data type, and basically anything with a binary data type, you need to use a different data type for that. And in our case, we have image data types. I don't have any var binaries in here, but essentially what you're going to do is you're going to take your data type, and I'll just show you in the categories. We have our text is okay, that works fine, but it's, again, the binary data types that the Postgres endpoint needs to have a little modification here. And what you're going to do is you're just going to go ahead and take that image or var binary max or whatever it happens to be, And I can do an easy replace here, where I'm basically going to take that image and replace it with byte A, and just comment out the image data type to remember what's going on. So I'm just going to go ahead and find next. And here I'm going to replace it. And then it finds the next one, and I'll replace that. And so now I have in my table this byte A. And you may be asking yourself, byte A, what the heck is that? So essentially, that is a Postgres native data type. And yes, you can use Postgres native data types in Babelfish with some serious caveats in that they may not always return something that's friendly to the TDS protocol. The TDS protocol expects some very specific things. The byte A data type, we've actually support in the TDS protocol to do the right thing. So when you query it with T-SQL, it returns the right prefix, and it looks just like a image data type or binary data type or var binary, that kind of thing. So it's a really nice hack to be able to use to get the DMS to work. Okay, so now that we have that, I'm going to now go ahead and run all my create table statements. And I'm just going to go down here, and away we go here. Too far. There we go. So now at this point, I could go into my cluster, expand out Northwind, and now I should be able to see my tables. There we go. Okay, so now I have all my tables created. So let's go ahead now and go into DMS and start setting this migration project. And again, I'm going to do it like the cooking session. I'm going to set up a source endpoint and a target endpoint. And then I've already created a replication instance, and I'll just show you what that looks like. And then we're going to create a replication task to go ahead and get that going. Okay. So I'll go over here and I'll go to the database migration service. And what I've done here is I've got the first thing you need to essentially do is set up your replication instance. When you do that, I'll just take a look. We'll just show you what it looks like through modify here, which has essentially all the same options. So you're going to give it a name. You can specify an instance configuration. If you have a very large database that you want to copy, and I say very large, that's like terabytes in size, you want to use a larger instance. So you can go all the way up to essentially 24x large with 96 cores. And what you can do is configure DMS to actually partition data, so each core can be copying over a particular partition of the data. And so by using a large instance, you're going to get a lot farther, a lot faster performance in your data migration. So something to consider. You'll always want to choose, in this case, the latest release is the 3.5.1 release, which just came out in the beginning of July. And there's this option for high availability. This is mainly used, you use this if you want to do a continuous load of data over time. So if you have like change data capture on SQL Server and you want to make sure you have the ability to fail over if something happens, you can set up a replica to be able to fail over to when you set that up. Allocated storage is primarily used for data validation and blob connectivity. So again, the larger the instance, the bigger the data that you have, you'll adjust the allocated storage size. Then in your connectivity, again, I'm using the same VPC group, so and it's in the same region, so it makes it easy to connect everything there. So those are the essentials. Basically, use 3.5.1. Okay. Next thing we're going to do is set up our endpoints. And I don't have any endpoints here, so I really do have to create them. And our source endpoint, I can actually select an RDS instance. Hopefully this will work just fine. And I'm going to choose my Express Edition here on RDS. I'll just leave the name the same. Provide the credentials here already are loaded in for SA, and the database here that I'm copying over is going to be Northwind. Okay, and there's this option here to test the endpoint. When you do that, again, you have to have your replication instance up and running, and you'll go ahead and run the test. And this basically goes ahead and says, hey, can I log in with the credentials you provided? And do I have enough permissions to do what I need to do on the SQL Server side to get the metadata and be able to do the data copy? Now, it's actually created the endpoint. I'm going to go ahead and create the endpoint so we can see it in action. And we see here, this is our endpoint for SQL Server. And if we go to connections, you'll see here it's still testing. Now, while that's testing, I'm going to go ahead and create the next endpoint. So go back to endpoint, and this is where we're going to use the Babelfish endpoint. But I'm going to do a little differently here because I know this will work. So again, with my endpoint identifier, I'm actually going to go over to Management Studio here, and I'm going to go to Properties in here and grab the identifier for my cluster here. And then I'm going to paste that in for the identifier. And that's just the name of it. That's not the actual service. So I'm just going to give it that. And then my target engine, this is very important. You're going to want to use Amazon Aurora Postgres. Okay, I've got that set up. I'll provide my credentials separately. So here's my server name. Again, this is my Babelfish cluster that I used. I'm going to use port 5432. That's the Postgres endpoint because I'm going through the Aurora Postgres endpoint. And again, my username and password is SA. Now, for the database name, I'm not going to use Northwind here. I need to use this Babelfish DB in Postgres. And then we're going to eventually map the schema over here. So for the database name, I'll use Babelfish_DB. And there's an option here for endpoints. And this is new with Babelfish. The latest release of Babelfish was 3.2 with Aurora Postgres 15.3. You need to add a couple of settings here to make Babelfish work. First one is database mode. And what you do here is you'll type in Babelfish, because this is going to give it a hint to use metadata calls. Instead of using a native Postgres metadata calls, use slightly modified versions of that to get the Babelfish metadata. And then you're also going to add another setting, which is called the Babelfish database name. And this is that virtual database that we created, which was Northwind. With those settings here, I'm all set up, and I should be able to now test my connection with the VPC and run test. And I'll hit create endpoint. So now if I go, while that's doing its thing, I want to go to connections here, and we see that our status is successful. If you get a failure in your status, it means you don't have the credentials set up. You may not have your security group set up. You'll need to diagnose that as appropriate. It could even be you mistyped your password name. But if you have successful mentioned here, you can actually create the task with it. Otherwise, you can't create the task. So that endpoint's good. Let's go back to our Babelfish or Postgres endpoint, look at connections, and it says successful. So what that's saying is that with the Babelfish database, it found that it was able to log in with the SA username. It was able to connect to the Northwind database. And so we're in a good shape right now. Okay, the next thing I'm going to do now is complete the The architecture diagram here is create the replication task. So we have our SQL Server endpoint, our target endpoint using Aurora Postgres with the Babelfish modifiers. We have our replication instance, now the task. So let's go to the task. And what I'm going to do here is I'll just say tasks and create a new task. So here I'm going to give it a name. Let's go Northwind. I'll just leave it at that. I don't have to get too fancy here. I choose my replication instance. Again, I can only see source endpoints that are valid. So I have my SQL Server on RDS, and then I have my target endpoint for Babelfish. And with the Aurora Postgres endpoint, you have the option of migrating existing data, which is a full load. You can also set up change data capture or replication to be able to do ongoing changes. This is the way that you would do it before you cut over to production. You do a full load and then do the ongoing changes to get caught up. And then when you're all caught up, you can cut over, with using DMS. So we're going to do a full load only. The other important step you're going to want to do in the table preparation mode is you're going to say do nothing. We already have our tables created in Babelfish in the right virtual directory with the right names and everything like that. What we don't want is Postgres to drop that table and recreate it as a Postgres table and not have the same meaning. So it's very important you always create your tables first and then do nothing for table preparation mode. And with this latest release of DMS, we now have the ability to do a full lob mode. So again, these lobs are fairly small, but if you have lobs that are, hundreds of megabytes or something like that, full lob mode is a very efficient way of copying it over in DMS. You can turn on data validation. I'm not going to do that right now. Well, actually I can, and I'll just show you some of the things that with our DMS integration. You can also turn on CloudWatch logs, which depending on how the job goes, it's useful to see kind of what commands were being executed. I also like to use the Postgres logs to see what SQL Server commands were getting sent over, but I'm not going to turn that on right now. And actually, I'm not going to turn on data validation just to save some time here. Okay, so selection rule. This is the rule for your target, where you're going to get your data. In this case, we're going to enter in a schema, and that schema name is going to be DBO. So this will allow us to copy over the DBO schema. You can create other tasks to do other schemas as part of the same database, or use the same one and just change the schema. Basically, then for table names, I use % to say take over all the tables. So this will say any table in DBO I want to copy over to my Babelfish tables. The next thing you have to do is add a couple transformation rules because we're in multi-database mode. The first rule that you always want to add is the rename of the schema. And so what you'll do is you'll say, for my schema that I have here that's called DBO, what I need to do is match it up again with that mapped schema. So back to here, I need to match it up, basically take DBO and rename it to Northwind _ DBO. So I'll say rename to, and then say Northwind _ DBO. Okay, so that'll make sure the tables go into the right virtual database with Babelfish. The other transformation rule I need to do is for my tables and for all schemas, I'm just going to say for all schemas and all tables that I ever want to do here, I need to make these names lowercase. So if I have mixed case names on my source and I have all lowercase names in Babelfish in my Postgres database, What will happen is if I don't do this rule, it will create the mixed case name in my Northwind DBO schema, but I won't be able to access that table because Babelfish doesn't recognize it as being a table created with Babelfish. So even though you'll see that in, say, dbeaver, if you're in Management Studio, you won't be able to see it. So to get around that, we make the name lowercase. We do plan in the future to make this a built-in rule now that we've added this Babelfish kind of mode so that it'll automatically do it. But right now, for the current release of DM, make it lowercase. We're going to say create, let's let it run automatically when we hit create. And I'm just going to go ahead and create the task. So we'll go ahead and let this create. And what I'm going to do is set up a little lesser known feature in Management Studio called a multi-database query. Now, why I like using registered servers here, in addition to being able to preserve the color, what I can do on a good day, and I'll say a good day depending on my network connectivity and all that, I can select the folder and say new query. And what that will do is open up a query window that you'll see is this pink or salmon color here. And you'll notice that it says down here at the bottom, it says connected 2 of 2. So basically, I now have my 2 servers. I can run a query against both of them at the same time. And to do this with Babelfish, there's under query options, you want to go to multi-server, and there's a couple servers settings that aren't the default. But what I like to do is I say, I want to see the login name, just make sure that's the right login name that I had set up in my connection. I show the server name, but more importantly, I want to say merge results is false, because if Babelfish didn't return a result, SQL Server did, the merge result ends up not showing up. So by not merging the result, you can see the results from one or not the other, depending on the nature of the query. But by setting it up like that, now what I can do is use Northwind. Ooh, look, I have what looks like IntelliSense here. Now, how did that happen? How that happened is because I named my RDS server with the 0 up here at the top. It shows up as the first one. IntelliSense will often come in when you're actually running this. So I'm going to go ahead and say, okay, go. And now both of my databases are set to, or both of the server connections are set up to Northwind. And what I'm going to do is hopefully double click on this multi-DB test query thing, and it will pick up the color. Yeah. So when you have a connection open and you open a new file, it tends to pick up that connection. So what this has done is actually said, hey, I want to go ahead and open up this file against multiple connections. And what I'm going to do is just say select top from categories and execute this. And what you'll see here is DMS has already copied the data over for that table and categories. And we can actually compare here the results. Since I like big fonts, we can see, kind of how they line up. If I move these here, I can see my description, and more importantly, I can see my picture data. Why that's more important is I can see that it's using, remember I had, we said it was using the byte A data type, but this data looks exactly like I'd expect for an image data type. And so the data moved over, but this is a great way to just quickly see that you got the data over without data validation necessarily in DMS, and be able to see what's going on with your data. So you can see here, I've got the right nvarchar values for German names that are in the SQL Server, and in Babelfish, I see the same things here. So great way to check with Management Studio with registered servers to see that the data is all copied over. And again, I could run this against all of them and see all the results. I'm pretty sure they all worked, because I'm going to go over now to DMS, and now you can see the load was complete. When I click on the job, you get, again, this thing called table statistics, and this will show you the tables, how long they took to copy over, and then again, the amount of size. So this all happened in less than a second. AdventureWorks, when I configure AdventureWorks to do this in demos, I can typically get that over in about a few seconds as well. With the DMS endpoint, I've taken a terabyte database and loaded that with Babelfish, with Postgres into Babelfish tables in about 19 minutes by correctly partitioning tables with a very large instance. And so again, you can copy terabytes of data as a part of a full load fairly easily with DMS, as long as you read the friendly manual. So the documentation's there to get you going. Okay, so now we have our data over. The next thing you want to do, again, in Management Studio, is now generate the rest of your database objects. And so what I do is I go into the Generate Script Wizard, and then I generate just tables again, but this time I turn off primary keys and unique constraints, and I select foreign keys, check constraints, defaults, triggers, all the various other things, and I generate that script. Now, oddly enough, in Management Studio, even though you told it to not generate the primary key, it does anyways, and it also scripts out all the tables again. So what I do is typically just select all the table goo and use the function in Management Studio to comment out the selected lines. And what this script will do is basically run all the index statements. And again, even if you have clustered indexes, because we have the escape hatches, it'll make all the clustered indexes non-clustered. But it will also create all the other constraints. I'm just going to go ahead and run this now. And again, I make sure I'm connected to my Babelfish. Nice little color coding. It uses Northwind, so that's good. So I'll go ahead and execute that. And okay, so what's happened here is that alter table no check is currently not supported. However, all these check constraints this just happens to be the way the Generate Script Wizard adds these things. So what it does is it goes ahead and says with check, and then basically it does the foreign key right here, like no check, and then it tries to do the check. But what happened is that those commands all failed. I could have used this escape hatches to ignore it, and I'm kind of curious why the escape hatches didn't work. But I basically get all my check constraints. And if you do get these errors and you thought the escape hatch didn't work, what you can do is go back and on the connection is again run the escape hatches that I showed you up at the top here of the original script. So again, I run this again, but you see now I've got all those objects. I'd have to drop everything and recreate them, and yeah, I won't do that here. Okay, so we've got that. We've got our views, and I'm just going to go ahead and create the views. And again, it was just going in and Generate Script Wizard and our stored procedures. And at the bottom of this one, I added a little test just to make sure the top 10 most expensive products work. So I'm just going to go ahead and run that. And when it finishes adding the stored procedures, we can see here that that procedure ran. Now, how did I know this would all work? And the way that you determine compatibility of your database with Babelfish is you need to run the Compass assessment report to determine if you've got any unsupported features. Okay, and the Compass assessment report is is an open source tool on GitHub, and so you can search for GitHub Babelfish Compass, and you'll see the Babelfish for Postgres, Babelfish Compass repository here. And what you can do is go ahead and download it through this link. This will get you the latest version. And there's a user guide that gives you all the information you need to know to how to use it. There's also a list of YouTube videos that have been created not only about Compass, but also some about Babelfish. We're working to expand our YouTube channel now, but this link here will show you all the YouTube videos that you have here. But what Babelfish Compass will do is basically go through, scan your T-SQL code. You can also do a profile or trace and save that as XML replay file as part of the SQL profiler, or you can use X-event tracing and basically use that to load into Babelfish Compass for your application code and determine compatibility there. And the way you run Compass, I'm going to use Azure Data Studio here to just run PowerShell script, where I'm going to go ahead and run a Compass assessment for my Northwind database. Now, I've already generated the code. Basically, I went into, again, the generate script wizard, and I said, turn everything on, let's see what works, and go ahead and run this, that's the SQL file here, that's the Northwind SQL. And I'll just go ahead and run that selection. And I'll point out what this command line is doing while it's operating. It's saying, go ahead and in my documents folder under Babelfish Compass, it's going to create a new folder called Northwind Report. It takes an input file as a SQL Server, a SQL file. This version of Babelfish Compass also supports now with the latest release the ability to connect to that SQL Server or connect to a SQL Server and provide a list of databases you want it to script and then do an assessment on it. The other option I chose was rewrite. And so there are some things that may be unsupported in Babelfish that Compass can rewrite for you in your T-SQL code to work around that particular option. And then the other option is this report option XREF. And this is really important because it allows you to then see in the result HTML file navigating, you can navigate to the actual issue that was found. And then another setting that was added relatively recently is this thing called optimistic. What this does, puts into the ignore category catalog objects or commands that aren't relevant to the application. A lot of times we'll see things like functions to look for the file group properties for the database size because you want to make sure your database size doesn't exceed its storage capacity on your disk. You don't have to do that on Aurora. So when we say basically comment those out or ignore them through escape hatches, and so we report them as optimistic. When you do that, there's two things that happen. First thing is you get a on Windows, at least when you run this, it'll also work on a Mac. It'll pop up the file explorer with the results here. And there's three main files in the directory. The first one is a CSV file with this results report XML that's already opened, and then version of that. And then because I had the browser behind the scenes, it opened up the actual result. Now, this Northwind one, just zoom in a little more. Again, it's showing you at the top, just saying, okay, here's the latest report when it was generated. Gives you the options that you use to set it and where the log file was for the actual Compass session. And then it provides, again, features not supported in Babelfish. It wasn't until this latest release, the 3.2 release, that we got that number down to 0. The first time we ran that was quite a bit higher. We finally solved the feature of set row count to and a value, and that's what that store procedure does, is show you the top 20 or top 10 items or top 20 items. Yeah. But the idea here is that if you want to see the features that were ignored, you can go click on this hyperlink here, and let me see. That wasn't quite what I expected. So here they are. I wanted to go to this section here, which is SQL features ignored because hyperlink didn't help. But these are the kinds of things that it ignored, like add extended properties. Now we have this feature in our roadmap, so expect that to show up soon, so you can do extended properties. But most of these extended properties tend to be things that were generated by the view designer, for example, in Management Studio. That's specifically what those were. So there's your ignored list. Now Northwind's not that interesting because it's Northwind, and we got that all nailed down. But let me show you how you can generate a report, say, for AdventureWorks. So because everything came back clean, that's why we could safely run code. Now, our research has shown that a fair amount of applications today will run clean when you run it. And so when you start with Babelfish, you may have thousands of databases in your portfolio. What you want to do is go after the ones that come back the cleanest, and specifically if they are if they have all the features supported, that's really easy. But for example, in AdventureWorks, that's a little trickier. And so I'm going to go ahead and run an AdventureWorks report. Now, to give you perspective of what it takes, the bulk of the work that I just did to migrate Northwind on a clean database, if I knew what I was doing, I could put this database, actually I know what I'm doing, I could put this database in production in about a day, knowing what Northwind does. We typically find that because a lot of customers are new to Aurora Postgres, that it takes a little longer. So your first migration to get into production for even a clean report can be, anywhere from a week to 4 weeks, again, depending on, how rigorous testing you want to do, what are the kinds of things that you think about in your deployment plan, your DevOps, being able to configure failback plan back to SQL Server if you need to, those kinds of things. Would determine, even on a clean report, you still have these migration things to consider. You may come into situations where your queries don't perform as expected, and we have things like the equivalent of show plan to see what's going on there. But in fact, I'll show a little demo of that in a bit. But you'll see in AdventureWorks here, there are quite a few features. These are the total counts, not necessarily the unique counts. We plan on adding the unique occurrences of these things in the future. But the features that aren't supported overall, we can get a glimpse of that here in the summary of not supported. And so we can see, like, error code. Well, this error code 3702 is database not found. This was used by the script to generate the Northwind database from scratch. And so this command here is not something you'd see in a normal app, but in a script to build a database, you would. So you could find another way to use, like check sys database to see if the database is there, or a lot of other ways. Same with the server property. It was also used as part of the create. Bulk insert, 69 instances of bulk insert. Well, that's because it was doing the inserts as part of the create there. Pivot, that's an interesting one. So we don't currently support pivot. There is a way to do that in Postgres using crosstab, and we're working on an article to describe how to work around that in the very near future. Other key things that aren't supported by default, geography data types. We can work around all the AdventureWorks scenarios related to geography using a Postgres extension called PostGIS. The GIS standard is the same standard that SQL Server uses. So all your point syntax and the binary formats and things like that are all compatible, and it's possible to work around it with the PostGIS extension. Hierarchies, a little trickier. There's another extension in Postgres called L-tree, which allows you to store hierarchical data. And you can come up with equivalents for doing that, a little extra effort. And also XML, in particular, XML value nodes exist. Those are things we can easily work around in Postgres syntax. And I'm actually working on a little article on how to convert nodes and values over for XML scenarios to handle the majority of the cases there. So even though AdventureWorks has got some unsupported features, it is possible to work around these things, but it may not be your first choice because, again, Microsoft SQL Server team put this together to literally demonstrate every feature in SQL Server, and now they have their newer sample databases that take that to the next level. But may not, AdventureWorks isn't typically, your applications don't have all those features that you'd find in AdventureWorks, for example. So anyways, that's what a more complex report would look like. Again, I would tend to go with the Northwind kind of ones with less unsupported features and say, an AdventureWorks classic report. But don't let this scare you at all. We have customers with we have a customer right now that's migrating over. They have 500,000 lines of T-SQL code that they're willing to invest in because they have a big enough SQL Server footprint that it's more cost effective to do that migration and then get it running on Aurora Postgres than it is running on SQL Server with all the cores that they've got licensed that they need to do it. So, it all depends on what your return on investment is going to be, comparing the cost of how you're running with SQL Server versus the cost of running on Aurora Postgres. And that'll make your decision on whether to go ahead and pursue a more rigorous migration project on a kind of a real breadwinner in terms of number of cores, and maybe skip over the smaller ones. But I actually recommend starting with the smaller ones first. Learn how Babelfish works, learn how the deployment process works, and go ahead and kind of understand the Postgres kinds of to kind of keep to make Babelfish perform as well as you can. One of those things that'll do a quick little demo of is the ability. I've got a little show plan demo here. So in our working with Babelfish, we've got a section on using explain, which is actually a little misnomer. What we have here is we have the ability to do something like very similar to statistics profile on, which will run the query and then provide a profile. You can go ahead. Let me go ahead and go to to Northwind here. And what I'm going to do is set Babelfish statistics profile on. Now, when I do that, when I run, I can, I'll see when I run a query, like select from categories in descending order of the category ID and name, right? So when I run that, I'll see down here a query plan. And this query plan is actually, well, it's a Postgres analyze plan. And so what you can use the various resources that are out there in the Postgres community to analyze this, but it's the thing that you focus on when you're looking at these plans is this cost. Now, this isn't seconds, it's like the cost to execute that query. It's very similar to some of those random cost settings that are available in SQL Server, like when you go into parallel mode or whatever. But you're typically looking at your cost values to see what's going on. You're also looking at things like the number of rows processed, all the things that you typically look at in a SQL Server plan. You would consider that for use those same techniques to refine your queries, to determine if you have your indexes all set up correctly, if it's using the indexes correctly. Now, this data is so small that it's recommending a decent plan out of the box, but when you have a lot more rows and you see your cardinality isn't what you would expect, hey, it's time to update your statistics. And the way you update statistics is with the analyze command. And we have information available in our documentation that shows how that works. The other thing that we added, I'm going to set Babelfish profile statistics off, is that you can also use the set config. This is actually a way to change configuration settings on their own using a Postgres function called set config. And I can actually say, hey, turn on that escape hatch. I don't want to use the stored procedure. I want to use this set config because it's cool. Now when I do that, I can actually use the same SQL Server commands, set statistics profile on, and then again, run this, and I'll see my query plan. Hopefully. Why aren't I seeing it? Oh, the demo gods are not being favorable for me. Did I set that? I did set it on. Profile. And okay, it's there. And if all fails, you just go to the Babelfish statistics. Let me just make sure. Okay. So we'll go back to here. Let's see. If you don't want to execute the query, you can also do Babelfish show plan all as well, and that will give you the query plan without the actual execution time in there. So those are two ways of kind of getting your query plans and then diagnosing those. With that, that's most of my demo at this point. We do, like I said, I mentioned that we do have the option, and you can read the documentation, how to use query hints. Again, not something I recommend. First, play with indexes, or rewriting the query before you use query hints. We always ignore no lock. Generally, no locks are bad, and so the thing to keep in mind is the transaction management for Postgres underneath the covers is basically using the MVCC, which is same as in-memory optimized tables in SQL Server. We do support the different transaction isolation levels. Not all of them are supported, but we can generally get you enough semantics so that your app works as expected when you're using your native client drivers. So what aren't good candidates for Babelfish? Basically, if you don't own the database code and you don't own the application code, Babelfish is not a drop-in replacement. For example, you're not going to be able to run SharePoint or reporting services or Microsoft Dynamics on top of Babelfish, because there are probably going to be commands that aren't supported in Babelfish that those tools use, and they're not good candidates. But for the apps that you own control over the application code and the dev code or the database code, those are the great candidates where you can get both the teams to work together to do the migration project. If you only have one team, like just the database team is doing the work for you, and you don't have the support of the application team, and you need to make modifications to the application, it's going to be a challenge unless you've got the teams working together to do that overall migration. So again, if you don't own the code and you don't own the database, Babelfish not a candidate. There are some features that are probably not on our roadmap where you want to use AWS native services as a replacement. For example, mail, our database mail or SQL mail. We have patterns as part of our DMS documentation for how you can use Lambda functions to do your email outside of the database, which is preferred. Another area that we're not likely to support is Service Broker. So if your app uses Service Broker, you want to see how you could probably rewrite that without Service Broker, or use things like AWS notification services or queuing services as a replacement for that. So with that, that's Babelfish. We've learned how, basically how you can set it up, how you can use tools like Management Studio to create your objects and run queries, validate the results. I didn't show how you'd actually hook up an app. I don't have an app for Northwind. But again, what you'll do is similar to moving your, if you're moving from one server to the other, you're going to change your connection string in your app, point to Babelfish, and then test. And so, for example, when you're doing that, and let's say the stored procedure here that I had at the end, which used row count when it didn't work, for example, you'd want to change this. You probably want to change this anyways to use top 10 instead of row count. But if there was functionality in a stored procedure, for example, and you didn't know to what extent it was called in your app, one thing that you could do is basically add a, at the begin, add a raise error command to raise error saying this is, need to do some work in this, and then literally comment out the code. And so the body of the procedure is basically there, but or the signature of the profile procedures there. And when your app code calls it, you'll get an error condition saying, hey, you need to work around this issue. And so that's one way of doing it. So when you're approaching a migration, what you want to do is get to a point where you get through create the cluster, get the data on there, as many objects as you can, and hook up the app, see if it works. Then as you're going through the app, you're going to look at core scenarios, and then for any of those unsupported features, you'll go ahead and modify your transact SQL code or use Postgres function workarounds and things like that to work around some of those things. With that, that concludes my demo. For your resources, what you're going to want to do is, again, go to the various sites that I showed here. DMS, just search for database migration services in the AWS documentation. For Babelfish, using Babelfish is a great starting point. If you want to learn all the nitty-gritty details of, hey, this seems like magic, right? How was it that the Babelfish team was able to extend Postgres with the Babelfish extensions to make it work? That is all documented in babelfishpg.org, and you can find that in the internal software architecture guide. And it has all the geeky things about how it all works in terms of being able to use the Postgres hooks, how we implemented the TDS protocol. This documentation is designed for people who want to work within the open source code base. And again, Babelfish is open source. That's the cool thing. And in fact, Alibaba Cloud, I think they're renaming their cloud, but Alibaba Cloud, their RDS Postgres, they had an RDS Postgres. They added Babelfish capability to that as well. And so other vendors are free to use this code and contribute to our code base, to make it more and more T-SQL friendly and work within their platforms. And we encourage that as AWS. The other nice thing about Babelfish being open source is you can actually set it up on-prem. So if you wanted to run on-prem before moving up to AWS and taking advantage of all the Aurora features, you can do that, for example, in the dev test environment. We've seen some customers do that already. So they'll set up, for example, Babelfish in a Docker container and then use that to set up their test environment. So there's all sorts of angles because it's open source, you're not restricted just to AWS. You can run it on-prem Linux. We don't have a build supported for Windows at this time, so you would need to know Linux there. But again, that is a nice alternative. And then, it'll be interesting to see if Microsoft ever picks it up, puts it on Azure or on top of their Postgres service. That'd be kind of cool. Anyways, I thank you very much. Any questions? We've got a little bit of time here before the end of the hour to take any questions.
Bill, what about link server?
What about link servers? We support it. Woo! Okay. So, what are you a plant? So starting with the 2.1 release, and so if you search for Babelfish for Aurora Postgres, you can see we've been doing a lot of work. And one of those features that we added down here, I think I've got the right one, is we added support for link servers right here. And what we do is we use what's called the TDS foreign data wrapper. And this is a Postgres extension that can talk to TDS sources, so SQL Server and Babelfish. And so you can set up a link server to a SQL Server or to a Babelfish cluster that way. But we're also looking to extend link servers to support other foreign data wrappers like Postgres data wrapper, right? So you could talk, basically connect up to a Postgres server. There's also data wrappers for Oracle, Redshift, and things like that. So that gives us a future path for implementing that. Now, in the April release, we did provide support only for Open Query. However, in the latest release, we added support for select statements. So now you can do a select statement with 4-part object reference naming. And we're going to continue to innovate on that to be able to eventually support things like execute, 4-part, a remote procedure name, or be able to do insert updates and deletes. So those are less common things than select statements. We wanted to get functionality out to customers as fast as possible, and so we're not, if we can get something working partial, we're going to ship it, right? So that's our approach. And we look at customer feedback that's actually on GitHub. So for example, if you want to submit issues, there's numerous ways. If you're an AWS customer, you can submit them through support tickets. But if you're not an AWS customer or full-blown customer or something, you can actually go to the Babelfish for Postgres project. And I believe it's Babelfish for Postgres here. And issues, maybe it's not that one. Might be the extension. Let me see here. Extensions. Issues. So what you can do is log into GitHub and file your own, requests. So we take these requests quite a bit. We also, if you're willing to share with us your Compass reports, we use the Compass reports to help define kind of those features we should be working on next. But GitHub is a great way to get our attention fairly quickly. If there's something that's not behaving right, you can submit a bug request here in the GitHub project for Babelfish extensions.
Bill, one more question. Any plans having SQL Server agent jobs?
SQL Server agent jobs. So I'll say this. SCT came up with a rather interesting extension to sort of kind of create SQL agent jobs, and underneath the covers run them through Lambda functions. We haven't tested any of that with Babelfish. There are numerous ways that you can call agent kinds of things through Lambda functions, for example, and open up a T-SQL connection and do that operation. right? That's one thing. Things that you might do like system backups, you're going to do that through the common language interface, and you could, I mean, Aurora as a service automatically does backups for you, so generally don't have to worry about that. But if there are other maintenance activities like, the equivalent of analyzing, updating statistics, for example, on a regular basis, you can do that through a Lambda function. You can also use an extension called pgcron, which on the PG connection can do some of these tasks on tables like rebuilding indexes. There's a command that you can use to rebuild all the indexes for a table in Postgres that works against Babelfish.
pgcron is basically a cron job?
Yeah, except it runs in the engine.
Okay, so it's not, I mean, you don't have to have a nuclear science degree to schedule stuff.
No, that's exactly it. Yeah, you don't have to go through all the learn Lambda, all that. You can use pgcron. The challenge is that pgcron doesn't quite run T-SQL things quite right because it's running on the PG connection. So as long as your PG statements, especially these maintenance things, which are compatible with Babelfish objects, you could run pgcron against those. We're looking at ways in Postgres that you could run a T-SQL command and give it context in the future as part of our interoperability story. We don't have that yet, but that's kind of some of the things that we're thinking about for our roadmap. So yeah, but pgcron is the simple way.
Got it, thank you.
Yeah. Another thing that we're also working on to copy virtual databases from one cluster to another. There's a command internally to, or part of the Postgres client tools called pgdump and pgrestore. We're making a Babelfish specific version that makes sure that it copies the T-SQL stuff out correctly. And then when you do the restore, it restores those objects and the security permissions that were associated with all those objects as part of the restore option. So that's on our near-term roadmap as well. So that's another thing that tends to, how do I copy my databases around once they're there? Well, that's the way you're going to be doing it. You can do it right now with the pgdump and pgrestore, but you have to have the SQL objects already created, and you can do the restore into those tables from whatever you used with pgdump. But that's a little more tedious than just being able to take all the schema and everything and move it over at one time. So that's where we want to go in the not too distant future. Okay, any other questions?
That's all questions for me. So eventually Babelfish is an extension of PGSQL that replicates some of the features of SQL Server.
As many as we can. That's right. It is not a translation layer, right? It is a full-blown parser that operates the same way the Postgres parser works. And internally, you're working with native Postgres objects, as if you were working with the Postgres language. So we literally built a new language. Postgres, supports Python and other different, Python and Lisp. There are other extensions out there for other languages that aren't part of the Aurora family, but we're using that native language extension model to be able to interact with the Postgres database as if it was a SQL Server database without all the hassles of file groups and things like that, right? So, there's no real performance penalty, for example, going through port 1433 and issuing queries. You can, if you look at the explain plans of a SQL Server query or a T-SQL query versus creating that query on Postgres, you'll see those execution plans are almost the same. because they're using the same indexes. Sometimes Postgres uses some index strategies that we haven't implemented yet in Postgres or in Babelfish. And when we find those, we get those into Babelfish as fast as we can. Right. So we're always trying to make sure that we're up with the latest query execution operators that Postgres has. So it's a great, again, it all comes down to cost benefit analysis. Start out simple. Don't try to take your most complex one to evaluate it. Start with a basic one. See if it works. Hook up the app, get it going, call it good, and then start, building muscle on getting other apps working until you get up to, the one that's really going to make that cost savings, based on those big apps. But it helps to get training on the smaller apps so that you build your confidence, you get used to the workarounds and that kind of thing. So that's how we want to approach it. So with that, thank you very much, Steve, for allowing me to present on Babelfish, and look forward to doing more of these with you in the future, hopefully.
Thank you, Bill.
Okay, Steve, Elena, it's great working with you.
Okay.
Thank you very much. Great presentation. I appreciate it.
Yep.